So one last example of the laws that we have studied is this. This is a single node pair circuit. The reason it is called that is because there are just two nodes here, because the top one, this is the first node, and this bottom one, this is the second node. So the first thing that I do whenever I see just two nodes and so many branches is I can apply KCL. So I'll just apply KCL at node A, and I'll write the sum of the currents. I can say that this is 120 amps entering, and I don't know the direction of the current in this resistor, the 1 by 30 ohms resistor. So I just assume that this is going down. I just assume all the currents in the resistances are going down. So as the current is I1 is going down, I write away from the node, I can write minus I1. This I2 is also going away from the node, so I can write minus I2. And there's 30 amps going away, so I can write minus 30. This is the equation. I can simplify it a little, and I'll write plus I1 plus I2 is equal to 90. Now the problem is that this is just one equation and there are two unknowns, just like in the previous example. So what I can do is I can use Ohm's law to convert this into an equation that has just one unknown. For example, I know that there are just two nodes here and here, and I know that if I apply KVL at any point, the voltage across every element would be the same, because whenever I'm measuring the voltage, I'm actually measuring the potential difference between two nodes. And because every element is connected between the same two nodes A and B, every element would have the same potential difference, which is basically V. So as the potential difference across 1 by 30 ohm resistor is V, I'll put the positive sign up because the current is entering from there. So I can use Ohm's law to write V30, or just V, is equal to 1 over 30 times I1. So I1 would be 30V. I can do the same for I2, which would come out to be V is equal to 1 by 15 to I2, and I2 would be 15V. So I can just substitute both of these into this equation here, and that would come out to be 30V plus 15V is equal to 90, which is 45V is equal to 90, and V would come out to be 2 volts. So the potential difference between node A and node B is 2 volts. So initially I apply KCL to find an equation that has two unknowns, and then I can convert those two unknowns into just one by converting them to the voltage using Ohm's law. When I find the voltage, I can find every unknown here. For example, if I want to find I1, I can just write V divided by the resistance, which is 1 by 30, which comes out to be 2 times 30 and 60 amps. I can do the same for I2, V divided by 1 by 15, which comes out to be 30 amps. So I found all the currents, and this is how you solve a problem called the single node pair circuit.